Hi, welcome back. So we are at the outline to discuss Pandas package. Now, Pandas is a kind of fast, powerful, flexible, and easy to use open source data analysis and manipulation tool built, of course, on top of the Python programming language. In this quick detour, we're going to just comprehend the understanding of the package and how maybe to go around it. So the first thing maybe we need to do is to understand how Panda or what kind of a data structure Panda is working with. Two important terminology you need to understand: series and work with data frames. Now, series basically is what we're going to start up with from mathematical perspective as a vector, and from NumPy perspective is an array, and from Python perspective is a list. Data frame, on the other hand, from NumPy perspective is a two-dimension, from mathematical perspective is a matrix, and from, of course, Python perspective is like list inside other list. Now, importing Pandas convention as PD, it gives you the access to Pandas package. I think in most of the project, seeing NumPy doesn't mean that you need to work with Pandas. However, seeing Pandas, most likely you're going to work with NumPy. Now, the first, as we said, data structure you need to understand is the series. And the series is one-dimension labeled array capable of holding any data type, such as integers, strings, floating points, numbers, Python objects, whatsoever. The simplest way to look at it, for example, if I would have variable and it is a PD, which is a panda.series, this is the function which expect two arguments. The first one is the data, and the second one something called the index, which is usually equal to a certain value of indexes. Now, this data can be Python dictionary, could be ND array, could be only a scalar. Data, if it is an ND array, index must be exactly the same length. Let me show you an example actually to make things better clear. I'm going to create actually MP array just like that. Now, Panda series using this MP AR, and basically we're going to indicate the index. Each value here, what kind of index you would like to attach to. So basically I could say, for example, A, B, C, D, and E, something like that. Now, how many values are here? There are 5. It should match exactly the number or the length of the data. That's the meaning. Both of them have to have the same length. To see what is the presentation of the output. So basically here is the entry of A, holding the first value, B holding the second, and so on and so forth. And then indicating, of course, on the output with the kind of a data type, which is a float 64. Now, the same thing if my data happened to be a dictionary. Let me here define actual dictionary. And basically, if I would have to run the exact same thing just by D, and I'm not going actually to indicate the index, I'll just run like that. Basically, the result as expected, every key and its value. Now, if the index is passed, the value in data corresponding to the label in the index will be pulled out. If I would have to get back here, and I'm going to indicate in the index this time. Now, basically, if I would have to run this one more time, we will get the result back. And something is quite interesting here. You could see that 1 and 0 and 2, they all exist. So I have the B, A, the C, but I don't have the D. So what really happened here, the corresponding values of the things that I don't have get back with a non-value. Now, another way also to look at the data as a scalar. So I'm going to create here a scalar value of 5, that's all. And I keep the indexes as they are. So watch carefully what happened. They're going to take all the indexes and then assign the exact same scalar to each one of them. Now, also maybe we could look at series as ND array. Series acts very similar to ND array. Operations such as slicing will also slice the index. What I'm trying to say here, if I would have to print here the S of 0. So it's going to return the first index of 0 to be the exact same result that I requested. Also, you might actually indicate something much more intuitive from the 0 until only the third. Printing this will get the first 3 indexes as expected. Also, maybe you want to do some kind of comprehension syntax like we did with lists in Python, for example, or also with NumPy. So basically, if I would have to say, well, I would like the S where the values should be, for example, example, larger than the value of the median. Just return values that happens, both of them, to be larger than the median. So you can see the comprehension in here. Maybe I can check also the D type of this Pandas series. It get me back with float 64 D type. Also, you could maybe check the s.array. It's going to return back a Pandas array. So it's exactly the same value and put them in a format of array. You could also convert that into NumPy. Instead now of being a Pandas structure, it's in the format of NumPy structure. Next also, maybe we can check something related to the series as a dictionary, like to print the S where the key, for example, is equal to C only. This is the value of this key of C, which is 2. You might want also to make a new assignment for that. I want this the S of C to a new value of, for example, 25. As expected, then this last value is going to be changed to 25. Now, working with a data frame. Now, data frame is two-dimensional labeled data structure with column of potentially different types. You can think of it just like a spreadsheet or SQL table or maybe deck of serious objects, etc. So basically, if I would have here to create a dictionary like this. Now, basically, if I want to convert this dictionary into a data frame, the convention is to call a DF or data frame is equal to the panda.data frame, then mention where is the dictionary you would like to do, which is the D, where we can see here the A and B and C and D, these are the indexes, and 1 and 2 actually the key of that dictionary. Now, when I mentioned only with these 3 indexes, it pulled out only these 3 indexes. Now, question, imagine if I would have to mention K and maybe a new more index W. Every value that you assume as an index and doesn't have value will return with none value. Now, you could also take this from a dictionary of any array, and the result is expected to be this is 1 and 2, and these are the corresponding values in here. How about if I would love to add one more extra index that is not equal to the length? So the length of this index is not equal to the length of that list. Exactly like series, I should be ran into an error. We said when we deal with list, it must be equal exactly the same length between the index and the length of that list. Now, next, actually, let's start to deal with Pandas by first looking at how to create objects, maybe to view them, etc. I'll see you then.